Hi there, I'm going to show you today how we can factor using a generic rectangle. This is also called the Xbox method. Let's start with an example. Today we're going to try to factor the quadratic expression 3x squared plus 4x minus 15. As the name Xbox implies, we're going to start with a box and an X. What two values can we already fill in into our rectangle? And where do they go? What we're going to do is fill in 3x squared and negative 15, the x squared term and the constant term, into our rectangle and make sure that they are diagonal from each other. I'm going to write them like this, but as long as they're diagonal, you should be good to go. Next, what do I know about these remaining values? In order to find them, we're going to set up a diamond problem or an X game, as you may have seen in Delta Math. So what do we know about these values? Two things. One, we know what they're going to multiply to. We know that when we multiply 3x times negative 15, we should get the same thing as when we multiply the two missing values. That means that these values are going to multiply to negative 45x squared, just like 3x squared and negative 15. That's what I'm going to write at the top of my diamond problem, because these are what the values multiply to. If we're going to match our original expression, 3x squared plus 4x minus 15, what do we know about the missing two values as far as what they add to? Looking at our original expression, we can see that that value must be 4x. Now we're ready to figure out what are our two missing x terms. To figure this out, I like to make a list of all of the factors of the number on top. There's infinitely many numbers that could add up to 4x, but there's only some numbers that you can multiply to get negative 45. Keep in mind that because we're dealing with a negative number, one of these numbers will be positive, the other will be negative. So I like to start from the beginning with the number 1. 1 times 45 is 45. That's one pair. 2 doesn't go in evenly. We also have 3 times 15, and we finally have 5 times 9. When I'm looking at these values, I want one of them to be positive and one of them to be negative. And I also want them to add to 4x. So the numbers that I'm looking for are 5 and 9. Here I can write 5x and 9x. Which of these numbers must be negative in order to add to 4x? That's right, we want to make sure that it's negative 5 because 9 plus negative 5 is like 9 minus 5, and that adds to 4x. Now we're ready to fill them in our rectangle. In order to finish our process, we need to find the length and the width of the generic rectangle that we've created. That means that we need to examine each row and each column to figure out what to multiply to get the inside. To start things off, I like to take one row or one column and think about the GCF. In other words, what's the biggest factor that is shared between 3x squared and negative 5x? The first thing I notice is that they both have an x value. So I'm going to write x here at the top. From the rest is just figuring out a puzzle. So if I have x here, that means that this has to be what in order to multiply to 3x squared? We're going to write 3x. If this is 3x, what does this number have to be to multiply to 9x? We're going to get 3. And finally, what does this number have to be here on the bottom left in order to multiply to negative 5x and negative 15? We get negative 5. At the end of the day, we're ready to write our answer. So we have 3x squared plus 4x minus 15. That's our sum because that's all of the inside parts added up. How do we write this as a product? We're going to take our length, x plus 3, and our width, 3x minus 5, and that is going to be our answer.